law, it'll be right there. Lenz's law, motional EMF, transformers. Okay, we'll talk a little bit about motors and generators. And we'll start off with a quick review of Lenz's law we talked about last time. So I've got two circuits side by side. The one on the right is a loop of wire connected with a resistor, no source of EMF, no battery in there. And the one on the left is a loop of wire connected to a battery. So we'll start at the top here. What happens when we close that switch? The instant we close the switch, what happens in this loop? What direction is the current in that resistor? In the right-hand loop, when we close the switch on the left-hand loop. So in the right-hand loop, current starts to flow. I'll draw that in red. Current flows. We good with that? Current flows. So what happens? That loop of wire acts like a magnet, right? Everywhere inside that loop of wire, what direction is the magnetic field? Into the page. Right? Everywhere inside that loop of wire, the magnetic field is into the page. There are two ways you could do that. One of the methods we learned yesterday, we said we can wrap our fingers around that loop like we're kind of grabbing something, and our thumb points in the direction of the magnetic field inside the loop of wire. Or I like to just treat it as a wire carrying a current. I would run my thumb along the direction of the current, and I know that the magnetic field encircles that wire. So on the inside, it's going to be pointed down. And what's it doing on the outside? Everywhere on the outside, in the plane of the page, it's going to be pointing up. So I can put some dots around here. So the loop on the right, a split second earlier, there was no magnetic flux through that loop. Now, there's a magnetic flux through the loop. So a current gets set up in that loop, and it produces its own magnetic field to counteract that change in flux. So we had an increasing flux out of the board, so a current would get set up to have its flux into the board. A current would get set up in this clockwise direction, so its magnetic field points into the board. Which means over here, it's going down through the resistor. Okay? Now we leave the switch closed for a long time, have some steady current. In the left-hand side, what direction is the current in the right-hand side? And the right-hand side Nothing is changing. Is there magnetic flux through this? Yes, there is. Is it changing? No. It's constant. And only a changing magnetic flux produces a current, produces an EMF in that loop of wire. So since B is constant, over here, I'll write it over here. B out increasing, and over here a constant magnetic flux doesn't cause anything to happen in that circuit. Matt?
I'm confused about the flow of the currents in part A with the with this being the flux. Can you go the other way?
Okay, back to part A. Question. On the left-hand side, you close the switch. The battery is going to cause current to flow this way. That causes a magnetic field into the board in the center of that and out of the board everywhere outside of it. Good. So this loop had no flux a second ago. Now it has a flux coming out. So a current gets set up with its own flux in to counteract that change. It always has to oppose the change. One way maybe to think of it, what would happen if it went the other direction? An increasing flux out causes current to flow. If the current that flows created more flux out, that would cause more current to flow, which would create more flux out, which would cause more current to flow. Free energy. We know that's not the case, right? We know we don't get something for nothing. So there's everything. It's always counteracts the thing that caused it to happen in the first place. So the increasing flux out has to cause a current to try to decrease it, to try to get it back to where it was. It had 0 before. It's going to try to decrease it back to 0.
So to decrease it to 0, essentially because it's creating its own in the other direction.
Right.
So that's where you get the trying to cancel it.
Right. It's trying to cancel it. But sometimes it tries to add to it, right? It always opposes the change. It tries to get it back to its previous state.